Hello everyone. Welcome to another Around the Block Talk. Today we have with us Mr. Kushagra. He's a blockchain developer and very passionate about this technology and the industry. So we are very excited to hear what you have for us today, Kushagra, and I'll hand it over.
Very good evening to all present, and thank you, Apit, for your kind words and for a warm welcome. So today I'll be discussing in brief about the Ethereum architecture, and for the same, I would be taking as a reference a great article which is uploaded on Medium by a veteran on blockchain space named Preethi Reddy. So just whenever I see people intending to uh, uh, talk about Ethereum or enter into this Ethereum space, always have a question that how do we get to know about what is blockchain or what is Ethereum? So we are intending to address this question. Along with that, we are intending to answer some of these questions which beginners usually face, as what is actually blockchain. So this is the brief agenda for our discussion. Uh, uh, a brief history of Ethereum. So if we talk of Ethereum or a blockchain in particular, so what is blockchain? This is a question which comes to the mind of all the participants and all the newcomers. So to answer that question, I would simply recite this sentence, that a blockchain is a shared immutable database of transactions between participating individuals, which can be used to validate or verify any exchange of value. So by these words, what I mean, that blockchain is simply a shared database. Like we are having a Google Drives. In Google Drive, we are having Google Sheets, which are mutually shared by all the participants, and we can collaborate upon that. So we can consider it as a shared database or a shared stored of value in which all the participants can view or verify a shared set of records. So in terms of blockchain, I would say each record is formed in a way that all the previous records are the details of all the previous records are held by the latest record or the block. So each record is stored in the form of a transaction. Suppose me and Arpit, we are transacting a share of a piece of value, or suppose we are sharing an exchange of value, like we are exchanging currencies, or we are for just record we are sharing some data, some currency or token transfer. So suppose we keep a list, we keep a shared you can say bahi khata, or a shared ledger in which we keep the records with this much transfer has been done. Suppose I made a transfer to Epic and it was of around 50 rupees. So I made a record or made an entry on that ledger. Now this entry could be stated in another way also, like I made a transfer of one asset which is stored digitally. So we can consider it as an NFT. So an asset which is stored digitally, and I transfer that ownership from my control to Arpit's control. So this is the example of NFT. Now we store that information in a database, or a ledger, which we call as blockchain. Now, what happens is that when this information is shared on ledger, it is mutually stored by all the participants in a peer-to-peer fashion, like we have in other peer-to-peer applications like uTorrent or Napster. So this database is shared by all participants. So if I destroy a copy from my side, it will still exist. Arpit would still hold that value. It will still hold that record. So the network can verify that I have made this transaction. So this provides a state of a sense of immutability to the system. Now, it also provides decentralization because it is not centrally stored by any participant. Now, one more feature which is added to this network, like suppose if I made transaction, now we need to verify whether it is valid or not, or it is complying with a certain set of protocols. So consensus mechanism comes into picture. Consensus mechanism is simply a way of knowing without including any third party to ensure that this transaction is verifiable or it is correct. Now, there are various mechanisms which have been developed in the recent days, which we call the initial mechanism to develop, which is known as proof of work. So basically, it is a cryptographic algorithm in which all the participants in a network uh, race to race to solve a cryptographic puzzle, and based on that, whenever that puzzle is solved, they can say uh, they poll it on the network that this transaction is approved by me to be valid. So as and when one of the miner or one of the person verifying that transaction polls or publishes it to the network that this transaction is validated by me or this puzzle is solved by me, uh, that transactions at that very moment that transaction gets validated, and this can be very easily now there is a condition that to solve that puzzle is very challenging. So it creates an effort. It requires an effort for the miner to solve that puzzle, which is required in form of computing power. So basically you have to calculate some values for the hashing function, based on which we can verify that this value exists for this hash output. Now, let me go in depth. I mentioned hashing. So what happens is that is my screen visible? I have opened the
Yes.
web page. Yeah. So let me take the reference of this article. So here it is mentioned that blockchain is basically a cryptographically secure transactional singleton state machine with a shared state. So this is, as it mentioned, it's a mouthful. So I'll break it down in chunks. Uh, yeah. So I'll just stick to this cryptographically secure argument. Uh, So they make it nearly impossible to create cheat system. So what happens is that in case of a traditional blockchain like Bitcoin, whenever this new transaction is made, the details of that transaction is converted into a hash, or it a hash through a hash function. Now, hash functions are basically some cryptographic functions which generate for a set of data. They generate a coherent sequence of characters which is unique to that particular sequence. Like, suppose I write a sentence like, "My name is Kushagra Agarwal," or suppose there is a transaction details between you and me. So, output of that would always be unique, and it would be a fixed sequence of characters. So, that hash is stored whenever we make a new transaction, or the transaction set of transactions is verified. Uh, the hash of the previous transaction is associated with the next set of a series of transactions. So this is how, if that previous transaction is verified by the miners, uh, that is the output of that hash function is the solution for that hash function is found by the miner. It is automatically validated, and anyone can verify that hash function, that hash function is correct. And since the hash function of all the previous transactions is appended to the next transaction, it automatically verifies that the entire sequence of transaction is valid. So this was a broad definition which creates a lot of questions. So let me go a bit deeper into it. So I'll start with my definition. So I was on to this immutable database part, right? So we were sharing the transactions or exchanges, and it was getting stored on the database. Now, we also discussed that it is cryptographically secured by some cryptographic functions, and to prove that this function exists, it requires a lot of processing power. And once it is proved, it is very hard to deny. It is very easy to verify, but it is hard to disprove either way. So, okay. And I also mentioned that it is a transactional singleton machine with a shared state. So let me delve into what is a state machine. So basically, when we talk of a state machine, so state machine is a concept in automata. Uh, if all the participants in computer science might have read this theory, uh, but I'll discuss it briefly. Uh, so state machine is basically a system in which we provide an input, and it provides a certain output or a definite output which changes the state of that system. So we can consider it as a function fx. Whenever we provide an input, it transitions to a definite state, and it provides a certain output. So in case of a transaction between you and me, uh, whenever that transaction occurs, so the state of that mutually shared database updates with one transaction appended. And when that transaction is verified by a miner, a state of that transaction is updated to previous transaction plus one transaction. And okay, so I think I need to explain blockchain also, because many of the participants might be not be knowing about blockchain. So let me create let me show
Kushagra, it's also possible to, we can directly get into a little bit of depth of Ethereum. And as you were mentioning, Ethereum 2.0, we can also go there.
okay. So uh, I'll conclude this to this part, that blockchain is a shared ledger, and all the transactions or all the exchange of values are stored in this ledger. So how do we convert it into the state machine? So as we made transaction into this blockchain, the state of the system is updated whenever this transaction is validated by by the miners. So uh, and in computing, we have a concept that state machine, or any computing device is basically a state machine, that we provide an input, it transitions into a different state, and it provides an output. And this is how we compute basically. So also Ethereum provided one functionality that in typical general blockchains, like in blockchains like Bitcoin, we were simply trading between transactions of economic nature, or we were simply making transactions of currency exchange. So Vitalik Buterin added one more layer to it, that what if we provide an ability for the blockchain to have transactions which can upload programmability to the network. So it introduced the concept of smart contract. So smart contract is basically a programmable logic or a protocol which is uploaded to the blockchain in the form of a transaction, regular transactions which you make, and it creates an entity called creates an entity called contract addresses. So let me discuss that. So yeah, I'll just share these details of how blockchain works. So yeah, so there are two types of accounts in a blockchain network. So one type of account is called externally owned accounts, which involves the accounts held by participants like us, and it contains addresses through which we interact with the network. So, and another type of account is called contract account. So this account cannot hold any other and it cannot be owned by any external participant like one of us, but it is owned by that programmable logic or smart contract. So whenever we create a transaction of smart contract, and this an external account, that transaction is done to an external account, which is generated as a contract account. So this contract accounts owns the data of this smart contract, and this provides us a protocol through which we can transfer value of other than monetary use case. Apart from currency, we can also transfer suppose land ownerships, or we can also transfer intellectual properties based on that protocol. So yeah, so I was prior to this,
can you explain a little more in depth? What is the difference between these two kinds of accounts? Do they have the same kind of permissions on the network, and what is the difference?
So yeah, so externally owned accounts are owned by persons like us, while contract accounts are owned by the smart contract. So they have some limitations, because contract accounts have some limitations that they cannot initiate a transaction like we can. So contract accounts only respond to transactions made by externally owned accounts or a fellow contract account. So it works in a hierarchy of command. Like for whenever we make a transaction to a smart contract, what happens is that as based on the protocol, we make a transaction. Like if we want a transfer of currency, so there is a smart contract uh, available in Ethereum through which we can exchange that currency. Or suppose if you want to transact an NFT, there would be an NFT smart contract. So based on their protocol, we will transfer the user can transfer that NFT. So this contract account will generate a new NFT, and it will provide the ownership of that NFT to the participant or the account which has triggered a transaction. So contract accounts only hold the addresses of only the data of the smart contract, and they only send messages to other smart contracts based on the stimulus provided by another external owned accounts. So this is their limitations. While yeah, so it is mentioned in this text that externally owned accounts can send messages to another externally owned accounts, or they can they can interact with contract accounts by creating and signing a transaction using its private key. So yeah, whenever we participate in the network, uh, in order to for the network to identify, uh, we whenever we make a transaction, we sign that transaction with a private key. So in accounts, yeah, so accounts are basically a two type of it is a basically a public key pair, a public key and a private key pair. So account address is generated by a public key of the pair, and while the private key is used to sign the transactions, create a digital signatures by signing the transactions. So based on that digital signature, any participant can verify that this transaction is be sent by this person or this account in the network. So when the external account sends that transaction to the smart contract, the smart contract will first verify that it is sent by this concerned account by checking the digital signature, and then it will initiate that transaction and do a processing and then transfer. If it is an NFT transaction or a transaction regarding transfer of ownership, it will perform the transfer of ownership of any entity or any asset from uh, from another account to that externally open account, or from the control of that smart contract to that external account. So it can also be it can also be used to create an asset from scratch. So in case of an NFT smart contract, I would show you a sample. Just a minute. I'll show you a sample smart contract. So here we are having a basic ERC20 smart contract. So for NFT or for any currency transfer, we are having some the keywords called ERC20 for basic token supply. We are having Ethereum, or we create a custom token or custom cryptocurrency, we call it by the protocol name called ERC20. And using this protocol, can create a new token in Ethereum block or any Ethereum compliant blockchain. So this is a basic source code for an NFT. So I'll just describe in brief that how it works. Any NFT smart contract will contain a very basic defining function called mint, and it will also contain a function called transfer. So mint is used to create a new asset or any new NFT from scratch. So mint is mint function. What mint function does is that it creates a new contract, and it creates a new NFT token, and it creates an address for that NFT token, and it assigns that ownership. If we trigger a transfer function, it transfer that ownership of that NFT from the smart contract to the concerned person or the concerned the concerned address. So how this happens or how this stored in the blockchain, let me revert back to the article. So this so whenever a smart Ethereum compliant or any blockchain, Ethereum based blockchain is created, we start with a state called Genesis state. My screen is visible. Yeah. So this is a blank state where no transactions previously occurred. So as and when a new transaction is made, uh, it is stored in the blockchain, and at certain points, these transactions are clubbed into a sequence of transactions known as block. So this block is basically a collection of transactions, and which is which is together approved or verified by a miner. Uh, and when the miner verifies or finds a solution to the puzzle to solve uh, to mine this block, it publishes the solution, and it publishes the message that this block has been mined, or this block has been generated. So when the block is generated, whenever the block is generated, the block of prior to the current block, the hash of that uh, the block prior to the current block is created, and that hash is stored uh, along with the details of the current block. So this works in the form of a linked list, or you can say a data structure in which the current node or the previous node current node points to the data of all the previous nodes. So it behaves in a similar fashion. So if a block uh, if a block contains the block hash of the validated block, so it implies that all the that block must be holding the details or the block hash of all the validated blocks prior to that. So for suppose this block ends hold the details of all the prior blocks, so it implies that the blocks prior to that holds the block hash or the validated the details of all the blocks prior to this. So it all points down to the genesis block. So basically, using cryptography, we ensures that the data is correct or in the entire blocks. So this sequence of blocks create a linked list, or you can say a chain. Uh, and this is basically this is how the blockchain term is coined, that a chain of blocks in which all the blocks contains the data of all the transactions. Each block contains a list, the details of transactions which it has mined, and it contains the details or the verified proof of all the previous blocks. So this is an immutable linked list, or a chain of records, or a proof of the records to be valid. So yeah, you as I mentioned, that there is a race between participants, or who are fighting to verify this block. Uh, so it can create a copy or a duplicate of different chains. For suppose one participant verified this block to be true, the upper one. So this upper block is known as fork. So and suppose all the other participants uh, started considering this block as valid block, and the chain extends to this length. So how to avoid fork? So there is a concept called ghost protocol. So ghost simply means that greedy heaviest observed subtree. So in under ghost protocol, we assign a block number to each block. For suppose uh, uh, when a block is validated, or it is mined, a block number is assigned, which denotes which is 1 plus the previous block number. So this is in this manner, we keep a record of how many records this current block is verifying, how many blocks the current block is verifying, and what is the strength, or what is the you can say weight of that current block. That if a block has a higher block number, it implies that this many number of blocks it has valid transactions for. So there is a protocol that the current node will always choose the block or the chain with the current block having the highest block number. So suppose in this we are having multiple forks or multiple duplicates of the blockchains. Then we will then the node or the participant will choose the block or the chain having the highest number of verified blocks. So suppose this is the length, this is the chain which is the longest chain in the network. This is called the canonical blockchain. So whenever a new consensus is made in the block in the network, we regard the canonical blockchain or the longest chain in the network to be the most valid or to be the most verified chain in the network. So this is how we create a consensus that the chain or the block, the latest block which is mutually considered to be true and can be verified by the block number to be the heaviest, is the most valid block. And this is how a consensus is made in the blockchain and the most correct chain proceeds in the network. So as we mentioned previously, there are accounts through which participants interact with the network, and account basically is a 20 byte sequence of data which is generated from the public key provided to the participant. So yeah, there are two types of accounts. So are you able to see the screen properly?
Yes.
So one is called externally owned account, as I mentioned, and another is called the contract account. So externally owned account will basically hold mm, the assets which have been transferred to this account. So suppose if an NFT is transferred to you, so it will be this account will hold the details of all the transactions which have been made to you. Now the ownership of the any asset will be held by the smart contract. So smart contract will keep the record of whoever which all participants or externally own accounts own the which NFT or which token of value. So this data is stored by the smart contract. Now how this data is stored, as I mentioned, that this blockchain works as a transaction state machine. So whenever a new transaction is made, so I'll just skip ahead and I'll show some data. Yeah, see, each block contains a block header. So block header is basically some metadata, like we have in our TCP protocol. We are having some headers which contain a metadata about each packet of information whenever we transfer information. So block header is a similar concept, you can say. It contains metadata regarding a transaction, the sequence of transactions to be correct. So the sequence of transactions is stored in a fashion of a tree. This tree is known as Merkle tree. So suppose as suppose you can consider it in a way that a transaction is made and so suppose in the bottom there is in the leaf there is mentioned as yo-yo 12. So consider it as a transaction that I transferred 20 tokens to Arpit, or consider that I transferred 12 tokens to Yo-Yo. So this denotes, or suppose this denotes a transaction, and in parallel there are sequence of transactions in this node. So a combined hash of this information will create another node. So suppose A8AKD. This is a hash of all these leaf nodes. Now this hash denotes the information or the data of this entire sequence of transactions. Now, when these hash of these transactions is again hash with the parallel the hash of nodes in parallel, then it creates another hash, and in a similar fashion we combine the hashes of all the nodes uh, up towards the root hash. So suppose uh, we suppose a tree or a graph of tree of these transactions is created up to this root hash. This root hash is stored by the block in its block header. So block contains the uh, roots of uh, three types of trees. So there are three types of Merkle trees created in the any transaction in any blockchain. One is called the state tree, state Merkle tree. Uh, Another is the transactions Merkle tree, and another is receipt Merkle tree. So receipts are basically you can say the uh, receipt of the transaction made between you and me of any transaction. So this the tree of those recept will be called receipt root. The root of that tree will be called receipt root. Now, in that transactions, in that receipt will denote to a transaction. So that transaction will have the information of what transfer of information took place between us. So it will all contain informations like I transferred this token or this NFT to you. Uh, so the information or the details of that NFT will also be stored in this transaction. So the tree holding all those transactions uh, and the root of that tree will be stored will be regarded as a transaction root. And then there is also called state tree. So what is a state tree? State tree is basically you can say uh, whenever uh, whenever consensus is made or a block is updated, uh, each participant in the network is having a copy of of the transactions which he or which is verified by that node. So that is their part of state or their share of state. So suppose you and me made a transaction and it is updated by a block. Suppose a third miner is updated that block, so it is a part of that miner state. And suppose in the meanwhile another are occurring in the other part of the network, remote part of the network, and it is the state of that their part, their share. So a collection of this state creates a canonical state or a global state of the network. So global state of the network, as I mentioned, is basically the mutually accepted canonical blockchain. It is denoted by the mutually accepted blockchain. Suppose there could be forks in between, but when the consensus is made, we consider each node considers the chain which has the longest number of transactions or longest number of blocks. So this creates a canonical state, and this state is basically held by a Merkle tree. So each state is clubbed into one combined state called global state, and this this root of or the combined hash of that tree state tree is called state root. So Also, this block headers holds the hash of the previous header called the parent hash. It contains something called nonce. So nonce is a term or an identifier which adds a complexity to the network, which adds a complexity in to the block, and based on that, like in Bitcoin, nonce is basically a number which is added whenever a transaction is mined. So uh, for that nonce, whenever a new transaction has to be mined, or whenever a new block has to be mined, the miner has to find a hash, which when added to it has to find a nonce when which added to the hash of the transaction, the block, verifies this that block creation. So if that correct nonce is created, then then that block is valid. So nonce is basically used in Bitcoin to add that complexity and add that token of verifiability. In Ethereum, it is uh, uh, it is uh, it is basically used to track the you can say track the uniqueness of this block, whether uh, how unique is this block. And difficulty is a term which is added to the block in order to create difficulty to in mining the next block. So difficulty is basically a number which is added. So whenever uh, a miner has to create a new block, uh, he this number gets added or incremented, and it creates more challenge for the miner to solve or generate a new block. So this adds value or a scarce this creates a scarcity of the reserve. So like in current blockchain of Bitcoin, in current scenario of Bitcoin, generating new Bitcoin is very difficult because of this difficulty parameter, uh, which creates a scarcity of or difficulty in creating a new block, and it adds a difficulty.
Sure,
So
sure. Just Kushagra, just keeping in mind the availability of time we have, can you discuss Ethereum 2.0 and
yeah, sure. So Ethereum 2.0, in the current scenario, we were discussing on proof of work, and proof of work is basically miner based. So it creates a challenge, and in based on that challenge, it creates a lot of pressure on computing power. So it costs a lot of resources while creating while running the transaction, while running the network. So we started with a new approach for consensus mechanisms, and the latest blockchains have shifted to a new approach called proof of stake. So proof of stake is basically a protocol uh, in which in which we assign the network randomly assigns uh, a particular node based on their stake. So stake is basically how much money or how much token you hold on the network, how much stake you have in terms of ether. Based on that, it randomly assigns and prioritizing that person having greater stake to validate or verify that network or verify the new block creation. So in proof of work, all the miners were participating, all the miners were competing against creating the new block. So it concurrently a lot of processing power was wasted. However, in proof of stake, a person is delegated by the network, which is in random nature, based on their or given the preference based on the stake. So one person is only assigned to validate or verify or create a new block. So this is a new approach which is coming into the picture. Along with that, along with proof of stake, the Ethereum is also intending to reduce the transactions per second, or TPS. So for in the present scenario, I believe Ethereum takes at least 10 to 12 minutes to verify one transaction, which is a minimum. So Ethereum 2.0 is intending to provide a TPS of around 500 transactions per second. So
So Kushagra, how does the TPS increase?
yeah, so TPS increase in a way that so let me explain the proof of stake consensus algorithm. So in this blockchain is keeping a track of set of validators based on their stake, and in the every slot of 10 seconds or so, they assign a validator on the randomly to create a new block. So since they are assigning a new validator to validate the block, uh, the mining time is getting reduced because you are not can say you're not fighting for mining or validating the transaction. Along with that, Ethereum 2.0 is introducing the concept of sharding. So in sharding, you have heard of layer 2 solutions like Polygon and Binance. So what they do, like the Polygon is a fork of Ethereum blockchain with a so all the forks of that blockchain contains a block number or the chain number through which each that blockchain can be identified. So what Polygon do, they implement proof of stake based blockchain, and they perform all the transactions on their chain. And whenever that a certain six number of blocks are created on their blockchain, they create a combined block on Ethereum blockchain and update their state on Ethereum network. So it creates a proof on L1 layer 1 solution. Along with that, the processing and the consensus are done on the layer 2 solution. So Ethereum is trying to implement that approach in-house. So through sharding, they are intending to create multiple forks or multiple side chains. So these side chains will perform consensus parallelly. So they will distribute all the transactions or all the transfer taking place into these separate side chains or parachains. And when the consensus is made, uh, that transactions can be uploaded to the main chain concurrently. So this is how instead of uh, creating and processing all the blocks on the main chain, these parachains will handle all the processing on the computation on the side chain, while the validation can be uploaded on the main chain. And this is how they are intending to improve the transactions per second. So
Right.
there are some
So
benefits. Yeah.
the main characteristic of Ethereum 2.0 would be proof of stake.
Yes. Along with that, you can also mention sharding. So through sharding, our scaling layer 2 scaling, they are intending to add this layer 2 scaling solutions in-house and baked into the system. So
And
this yeah.
how does that work? What are they doing to break that into the system?
So they have created a new fork. So as you have heard, the last fork was Istanbul. So recently they have and recently they have created a new fork, and which implements proof of stake functionality to Ethereum. Now each transaction also holds the data of the chain number and the protocol or the algorithm which way they are following. Like, are they following proof of work or they are following proof of stake? So if it is they are following proof of stake consensus mechanism, then their transactions would be uh, handled by proof of stake fork of the blockchain. Or if they are if the participant is working on typical Ethereum 1 Ethereum or Ethereum Classic, then it will be handled in proof of work fashion. But now the main chain, since the main chain has will be shifting towards proof of stake or the latest fork, the longest or the most valid chain would be the latest fork of Ethereum. And so proof of stake would be the dominant protocol in making the transactions. So this is what will this will what will act for the gradual shift of Ethereum from Ethereum 1.0 proof of work to proof of stake. So the challenges which occurs, which will happen in between, are mainly minor oriented. That because there is a huge industry set up by the miners, which leverage the proof of work mining protocol, while proof of stake does not. Yeah, so there is a catch in proof in the latest fork, that the mining fee, uh, the mining fee would be a fixed mining fee, so as to reduce the cost of running the transactions. So due to that, the incentive which is provided to the miners would be reduced. So that is why there was a friction for Ethereum to shift from Ethereum 1.0 to Ethereum 2, because of that, the shift got delayed. However, now the Ethereum has shifted to proof of stake, and we are expecting for the network to have a higher transaction per second.
When is it already implemented, or when is this going to be implemented?
So proof of
Ethereum
stake
2.
is proof of stake. Ethereum fork of proof of stake has already taken place. So as I mentioned, uh, Ethereum, whenever a new chain or a new chain is created, it is called a fork. So Ethereum committee occasionally announces of hard fork. So hard fork is basically when the Ethereum community shifts from one chain to another chain, or creates a branch which is considered uh, the next valid branch of the blockchain. So this is usually done to improve on protocols or improve on security, or to add new functionality to the blockchain or Ethereum. So, or add new compliances. So it is a gradual cycle. In terms of frameworks, we are having the uh, occasional version upgrade. Similarly, in Ethereum also we are having the occasional hard forks. So the current hard fork has already taken place from proof of work to proof of stake. So yeah, right now it is available.
Sure, Kushagra. And Kushagra, I'm sorry, but we have expired 1 hour of our talk. So I think we
So yeah,
can, if it's okay, we can close it here for today.
sure. So so can we have a are we having a Q&A with the participants?
Yeah, so it's usually a recorded kind of a talk. So I think it's me and Arpit who are there on the call, and so we will now we will kind of edit this talk and release it on YouTube channel.
So any further questions you like to ask?
I think you've explained that. So one question that I do have, that although it would improve to 500 TPS, but I don't believe that is sufficient to actually support the kind of ecosystem that has come up. So how
Yes.
do we actually achieve
So
thousands in
yeah.
TPS.
So theoretical limit for the same is around million TPS, but they are claiming at present around 500 TPS. So in the current scenario, the available blockchains, for suppose Polygon TPS, if we talk of Polygon TPS, so it is around 500 transactions per second. Yeah. So let me share a current comparison between the blockchains. So right now, when we talk of TPS, yeah. So there is always an issue in terms of scalability, security, and decentralization, which hinders the transactions per second. So scalability refers to how many transactions we can have per second and how can we scale it to a higher number. Security refers to how we can ensure that this transactions does not get reverted, or any uh, unfair transaction or unfair uh, fork does not happen in the blockchain, resulting in illegitimate transfer of value or a loss of value. Like we had one hack in Ethereum back in 2016, due to which we Ethereum had to do a hard fork. So uh, we need a strong consensus mechanism. So which in terms in such scenarios add the effort of more processing, and it reduces the time to mine a transaction. Along with that, we also have to consider decentralization. That if we suppose keep an auditor or keeping auditing node, it will ensure the higher transaction per second, but it will hinder decentralization. So due to this trilemma, there are platforms which have claiming to work solve this trilemma and achieve a higher TPS. For suppose Solana at present claims to have around it is mentioned 86,400 transactions. So however, Solana at times in crypto community, uh, Solana is sometimes criticized for its centralized nature, in terms of since it has some admins, while purely decentralized network is only Bitcoin as of now. So and Ethereum. So uh, this is also a challenge in terms of uh, in terms of scalability, security, and decentralization, which all the major blockchain systems have to address at present. So for Ethereum to scale, I believe Ethereum has to consider all these factors. For like as you see, Solana, yeah, as we can see in terms of TPS, Solana is far higher, is having a far higher TPS than all the other competing blockchains. But Solana is having a kind of centralized nature. So in real execution scenario, all the blockchains are close to 50 TPS, and Polygon has a higher TPS. So they claimed around 500 TPS, but theoretically they claim to have a TPS of around million transactions per second. So it all boils down to the consensus mechanism which they are using. That how many transactions, like how conveniently they can uh, verify the nodes, how quickly they can their consensus mechanism can create a mutual consensus throughout the participants, and how many transactions they can accommodate. So for having a large number of transactions to execute concurrently, they are using the concept of sharding, or using uh, side chains. So side chains is creating a theoretical TPS of a million transactions per second, but still consensus is the bottleneck in the actual execution. So it all boils down to the choice of consensus mechanism. So this is an active field of discussion. So yeah, as you mentioned, how will they achieve a higher TPS to be economically feasible? Uh, I believe Ethereum team is working on improving on the consensus mechanism by regularly introducing Ethereum improvement protocols proposals, and work is being done in improving the current consensus mechanism of proof and stake. So as to uh, improve the mutual consensus time, and accommodate more transactions through side chains. So to answer that, to sum up your question, I would say improvements on consensus mechanism is the way to improve transactions per second.
Sure, Kushagra. Thank you for answering that question. And thank you very much for taking out time to present this talk to us today. And it was great to host you.
So it was my pleasure to join the talk as well. So it was great talking to you all, and it was a great and fruitful session.